this is part 1 of your Unit 7 task review. Let's get started. Oh, also, remember that this test also has Units 5 and 6 on it, so be working on the review packet for that. Alright? So, in the figure below, which two lines are parallel and which line is our transversal? Easy. R is parallel to S, right? And Q is our transversal. Okay, not bad. Alright, in the figure, if the measure of angle 1 equals 28, what are the following angles that explain your reasoning? Well, measure of angle 2 is 152, right? Measure of angle 2 is 152 because they are a linear pair, right? They're adjacent and they're supplementary, so they're a linear pair. Okay. Measure of angle 3, vertical angles with the angle 1, so that's 28 degrees. Measure of angle 4, right here, corresponds with angle 2, right? So it's 152 degrees. We know that because of corresponding angles with angle 2. This one, vertical angles with angle 1 okay? So now let's look. So this is 152. Number 5 is a linear pair with angle 4, so that's 28 degrees. Okay, number 6 is also 152 degrees. Right, because that is a vertical angle with angle 4. Angle 7, 28 degrees, corresponding angle with angle 1. And finally, we have the measure of angle 8, right, which is 152. And for this one, there's a multitude of answers, but I'm going to say 52 degrees because it's alternate interior angles with angle 4. I hope you see that. Okay? So take a minute to get this down. Pause the video if you need to. And I am going to move on. Number 3, complete the following 2-column proof given that K is parallel to P and prove that the measure of angle 1 equals the measure of angle 3. So, we have our given, K is parallel to P, right? We draw that it's parallel. Next, we're told that the measure of angle 1 equals the measure of angle 2. We know this because they're corresponding angles, right? So next we're told vertical angles. Well, the only two vertical angles that are marked in the picture are angle 2 and angle 3. We're going to keep the format that we've been in so far. So measure of angle 2 equals the measure of angle 3. Okay? Finally, we put right here what we're trying to prove, right, because it's the last line. So measure of angle 1 equals the measure of angle 3. We look here. We see measure of angle 1 equals the measure of angle 2, and the measure of angle 2 equals the measure of angle 3. So we can just cut out the middleman, right? Get this, And that's substitution or the transitive property of equality, whatever you want to call it. I'm going to write substitution because it's shorter. All right? So take a minute, write that down. Okay. Number 4, complete the following 2-column proof given, we're going to put our given right here, right? That angle WVX and angle QST are supplementary, right? That's our given. All right. So now we have the measure of angle WVX plus the measure of angle QST equals 180, which is basically this, just written in a different format, right? So that's the definition of supplementary angles. Next, we see measure of angle QST and the measure of angle TSV equals 180 degrees added together. That's not the definition of supplementary angles, okay? Because we don't have it written up here, so there's no format to change. All right, we know this is true because they're a linear pair. All right? All right. So we have these both are equaling to 180, so we can just cut out that middleman. Set them equal to each other, right? That's substitution, or the transitive property of equality, whatever you want to call it. All right, so now we have a blank space. So what I would do next is take a look at this, see if there's any duplicates. There are, right? Measure of angle QST. So we can just get rid of that from both sides, right? And we get the measure of angle WVX equals the measure of angle TSV, right? And we got that because of this. We do this all the time in algebra, right? Subtraction property of equality. And finally, we can put what we're trying to prove. UW is parallel to RT, right? So we have WVX, this right here, is congruent to TSV, that's this right here. So in order to prove that they're parallel, these are corresponding angles, right? So two corresponding angles are congruent if the two lines are parallel. So the converse of that is if the two angles are congruent, then these two lines are parallel. So this is the converse of corresponding angle, right? Okay, so that's that one. Number 5, is it possible to form a triangle with the given side lengths? Explain why or why not. Okay, so this one we would do you remember you add the two, in order for it to be a triangle, two of the side lengths, when you add them, have to be greater than the third side length. Okay, so we have 16 plus 12 equals 28. Which is greater than 14, right? So this checks out. We have 16 plus 14 equals 30, which is greater than 12. So this checks out. And we have 14 plus 12 equals 26, which is greater than 16. So this checks out. So the answer is yes, this can be a triangle. All right? So let's look at B. All right? 21 plus 22 equals 43, which is greater than 3, unsurprisingly, so that checks out. 21 plus 3 equals 24, which is greater than 22, so that checks out. And 22 plus 3 equals 25, which is greater than 21, so that checks out. So yes, this can also be a triangle. All right? Now C, we have 7 plus 20 equals 27, which is greater than 13. This checks out. 13 plus 20 equals 33, which is greater than 7, so this checks out. And 20 plus 7 equals 27. Now, that's not right. 13 plus 7 equals 20, which equals 20, right? It's not greater than 20. It can't be greater than or equal to. It has to be greater than. So, this does not check out, and no, this is not a triangle. So let's look at D lastly. All right, we have 2 plus 3 equals 5, which is less than 9. We have 2 plus 5. Everybody say hi to Sam who just walked in. 2 plus 5 equals 7, right? Which is, what am I doing? 2 plus 9 equals 11. There we go. Which is greater than 3. This checks out. Didn't remember. 3 plus 9 equals 12, which is greater than 9. So this checked out. But since this didn't, the answer is no. If two sides of a triangle are 27 inches and 15 inches, Sam, can you shut the door? What is the inequality for the third side denoted as x? So we have 27 plus 15, right? These are two sides of the triangle. It has to be greater than the next one, right? So this is 43. Okay? So, what we would do, we have x, right? Denoted, by the way, means written as. That's all it means. So right now we have x is less than 43. Not less than or equal to, less than 43. But we also need the other side of the inequality. All right? So what we would do is we would just subtract. 27 minus 15 equals 12. So x has to be between 12 and 43. So that's how you do this one. All right? For number 7, we do the exact same thing. So we do 19 plus 5 equals 24. So y has to be less than 24. Now we have 19 minus 5 equals 14. So y has to be greater than 14. So that's how you do those. All right? All right, number 8. There was a bit of an issue with this. I guess it just showed up incorrectly. This is not an equilateral triangle. All right, this is different than these two. All right. So solve for x and y. Okay. So we know all the angles of a triangle have to add up to 180. So we have 4x minus 6 plus 3x minus 2 plus y equals 180. All right? We also have, since this is an isosceles triangle, y equals 3x minus 2. Okay? So So we can plug this in for our y right here. So we have 4x minus 6 plus 3x minus 2 plus, once again, 3x minus 2 equals 180. Okay? So we collect like terms. We end up with 10x minus 10 equals 180. 10x equals 190. X equals 19. So if x equals 19, which I'm going to write over here, we plug in for y, right, which is 57. So 57, right, 19 times 8 is 57, minus 2 equals 55. So y equals 55. All right? That makes this 55 degrees, this 55 degrees, and this would be 70 degrees. And if you plugged in for x all around, you would get that. All right? All right, number 9, solve for x. All right, do you guys remember this exterior angle theorem? Probably not. Basically, this is saying that these two angles, when added, equal this angle, right? And this is easy because if this whole thing is 180, right? This is supplementary to these two angles added, right? But it's also supplementary to this angle. So these two added equals this. Simple. All right, so we have 9x plus 16 plus 6x plus 15 equals 19x plus 13. Plus 30, sorry, 19x plus 30. So we combine like terms, we get 15x plus 31 equals 19x plus 3. So subtract, we get 28 equals 4x, 7 equals x. All right? That's it. Okay, number 10. Are the following triangles congruent? If so, write a congruent statement for them. Are they congruent? Well, we can tell. This angle matches up with this angle. This side matches up with this side. This angle and this angle match up. So we end up with these being congruent by angle, side, angle. And we would write our congruent statement as triangle ABC is congruent to triangle DEC. Alright? I hope that everybody sees that. Excuse me. I hope you all see that. Alright, number 11, draw an example for each of the following postulates. This one's really easy, I promise. It's just like, this marker is no good. None of them are any good, unfortunately, it seems. Probably not that one. Yeah, okay, this one's great. So side, 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 and side. These are congruent. Alright? Side, angle, side. We draw our two triangles. Side, angle, side. Side, angle, side. Those are congruent. This one, angle, side, angle. Angle, side, angle. Angle, side, angle. And that's it. Alright? angle, angle, side, we have angle, angle, side, angle, angle, side. Alright? Finally, we have hypotenuse leg. Hypotenuse leg only applies to right triangles. Alright? So we have these right triangles. Hypotenuse leg means that it has a 90-degree angle. One of the legs, at least, match up to another leg, and the hypotenuses, hypoteni, I don't know what it is, plural, are congruent. It could have also been okay? Another way to do that. Alright? Those are our two options for that one. Alright. Number 12. I don't know why it says this. Don't worry about that. So just do this proof. Given PQ is parallel to RS, right? Just going to redraw that for my own knowledge. And angle PRQ, right, is congruent to angle SQR. All right, that's written here. So that's our given. We need to prove that triangle PQR is congruent to triangle SRQ. So, these are our parallel lines. We know that. This is a transversal. All right? This is a transversal. As is this, okay? All transversals. All right, so we're told this already. Now we're told alternate interior angles. Well, what are two alternate interior angles in here? These two angles, right? So angle QRS is congruent to angle PQR. Okay? Finally, we have this blank space. This is for the reflexive property of congruence, right? This is equal to itself. So RQ is congruent to RQ, right? Common sense, but it forced us to mark it in the picture, right? So this is the reflexive property of congruence. And finally, we have what we're trying to prove, and we have this through angle, side, angle, right? Okay? So that's how you do that. Oh, I see what that is. A question accidentally got covered up, and that's why. So I built it stuff like that. That's okay. Nothing in the world. Right? So here's another proof. So given, write it here, given angle NER is congruent to angle NVR, and RN bisects angle ERV. An angle bisector means it cuts the angle in half. So this is our angle bisector, so this equals this, right? Right. So, the definition of an angle bisector, since this, right here, is bisecting this angle, right? ERV, we know that these are equal to each other, those two angles, right? Because it cuts ERV in half into two equal halves. So angle ERN is congruent to angle NRV. Alright? So now we have another blank space. We can go ahead and say that's congruent to itself, right? Rn is congruent to Rn, right? Reflexive property of congruence. And finally, we have what we were trying to prove, and we got that through angle, angle, side. Okay? Alright guys, this concludes part 1 of the video. If I make it too long, it's really hard to upload to YouTube. So I'll see you in a bit for part 2.